Hi everyone, welcome back to Lulumath. This video is on domain and range of relations and functions. And I just want to mention that domain and range is a huge topic. And so we're just doing a quick overview of what domain and range mean. And then when we look at specific types of functions, we'll get more in detail on how to find domain and range of these functions. So again, this video just serves as a basic introduction to domain and range. So you'll need to know what a function is, and you'll need to understand examples and non-examples of functions. All of that information is at lulumath.com, as well as the Lulumath YouTube channel if you need a refresher. So for starters, we need to define what domain and range mean. So the domain is the set of all inputs or x values or independent values that satisfy a relation. And the range is the set of all outputs or y values or dependent values that satisfy the relation and the domain that is defined by it. And these topics can get a little bit tricky depending on the type of relation or function you're looking at. But the more in-depth understanding of the domain and range of each specific type of relation and function will come in future videos. So in our first example, we're asked to define the domain and the range of each relation below. And just a reminder that the domain is the set of all inputs and the range is the set of all outputs. And in this example, this is considered a discrete example because our points are specific points. They're things that I can list out. So our domain and range for these types of questions are nice. They're not too difficult. So for our domain, if it's the set of all inputs, they consist of our x values. So looking here, I can see that my x values are -5, 3, 14, and 5. Now, generally, we put our domain in numerical order from smallest to largest, but we don't have to do that. It's just convention. It's typical convention. So that's what I'm going to do here. So I'm going to list this from the smallest integer, which is -5, all the way to my largest integer. So if you see, we've got -5, we've got 3, we've got 5, and we've got 14. Now our range is simply our set of outputs. So here our range consists of 2, 7, -9, and -1. Same thing, I'm going to put this in numerical order from least to greatest. So my smallest value is -9. You don't have to do it this way, but it's generally better to do it this way. -1, 2, and 7. This is my domain and range of this relation right here, which also happens to be a function. In this relation, we're asked to find the domain and range again. And this one is also a function because each input has only one output. And just a reminder that your domain is the set of all inputs and your range is the set of all outputs. So our domain are the values that are listed out here. So -6, -4, 0, 2, and 3. And our range is the values that are listed out here. So -5, -4, 0, and 1. One quick note is that a common mistake that people will make is they'll say that the domain here, for example, is from -5 all the way to 14. But what this is saying is it's every single possible value from -5 to 14. Every fraction, every decimal, everything. This has infinite values here, but our domain consists simply of 4 distinct numbers. And the same thing is true for our range. A lot of people will accidentally say that our range is from -9 to 7, and we use y here because our range is our set of outputs. But again, this is incorrect because what this is saying is every single value from -9 to 7, but we only have 4 distinct values from -9 to 7 that will work for us. And people will make that mistake with this domain and this range as well, so you just want to be careful. We need to actually list it out. Now, this is where we get into the nitty-gritty of everything. Again, we're just going to do a quick understanding. We're not going to get into too much detail. Our first relation that we want to find the domain and range of is y equals 4x minus 3. And this relation is a linear relation. And in the vertical line test video, we had mentioned that all linear relations are functions except for vertical lines, but this is not a vertical line. So we can actually call this a linear function. And this is what our graph looks like. Y equals 4x minus 3. The y-intercept is -3, and it has a slope of +4 over 1, +4 over 1, so on and so forth. Now, our domain is the set of all inputs that work. And this graph goes on forever in both directions. So if you see here, since our equation says y equals 4x minus 3, can you think of any x values that won't work if I were to plug it in? I could plug in tiny numbers, large numbers, fractions, decimals, you name it, even irrational numbers, rational numbers. Any real number that I plug in here will work for us because I can do 4 times any number minus 3 and I'll always get an answer. Also, because my graph goes forever in both directions, there is no end limit on the left side and there's no end limit on the right side. I can continue to go further and further left and further right. So therefore, my domain here is all possible values. So we're going to say the notation is x is an element of the reals. Essentially, what this means is x can be any number from -infinity to +infinity. And this right here is interval notation, which you can find a video on at Lulumath.com, as well as the Lulumath YouTube channel if you want a better understanding of how to do interval notation. But essentially what this is saying is every x value from -infinity to +infinity works. Now, sometimes when we're finding domain, it's easier to ask yourself, what doesn't work? And the answer to that question in our linear function is nothing. Every single x value will work. Now, for our range, our graph is everywhere. It goes all the way down and all the way up because it extends. So again, there's no lower limit and there's no upper limit. It will go on forever. So we're going to say y is an element of the real numbers. And that's how we get our answers for our linear function. Our next example that we're going to look at is y equals -2x squared minus 5x plus 1. And we know that this is a quadratic relation and that it opens down because our a value is negative. We also know it's a function because we learned in the vertical line test video that all quadratic relations are functions. So remember, the domain is the set of all inputs that work. And the tip that we have here is when finding domain, sometimes it's easier to ask ourselves, what doesn't work for x? I'm going to see, are there any x values that I can't plug in? I can put in any x value that I want. I can plug in 3, I can plug in -7, I can plug in 2/3, I can plug in pi. It doesn't matter what I plug in, I'm always going to get an output. There's no restriction on my x value. Let's take a look at what our graph looks like too. So this is what my graph looks like. And as you can see, there is no restriction again on my x values. My x values don't have a limit on the left side, so I can keep going to the left, to the left, to the left. There will still always be some corresponding y value because my graph will go on forever in both directions. So since it's both directions, same thing with on the right side, it'll just keep going and going and going. Every x value that I try to plug in will work. So here we can say our domain is that x could be any number from -infinity to +infinity. So we'll say x is an element of the reals. X can be any real number. So again, from -infinity to +infinity will work. So just a reminder that range means the set of all outputs. We didn't put this down in the last example. And our range is a little bit trickier in this example because unlike the linear function where it extends to infinity in both directions, our parabola reaches either a minimum point or a maximum point, which is the vertex. If it opens down, it reaches its maximum, and if it opens up, it reaches its minimum. So essentially, our outputs can only be all values up to this point right here and nothing above there. And then if it opened up, then our range would be all values from this point upwards. So I need to determine what my vertex is. And there are a lot of different ways to find the vertex, and there are a lot of videos on that if you want a refresher. But I'm just going to use the technology to help me out so I can get a quick answer. So using Desmos, I can see that my vertex is -1.25, 4.125. So when I'm trying to find my range, I can see that my range is every single y value that's possible all the way up until I reach my 4.125, because again, range is a set of outputs, so we're only going to be looking at our y value. So for our range, we're still going to say y is an element of the reals because it could be any number up to 4.125. It doesn't have to be specifically an integer or a whole number. It can be any number at all, but y has to be less than or equal to 4.125 because it reaches 4.125, and that's the highest point it reaches. And we say equal to because it actually touches 4.125. Or in interval notation, we could say that it is from negative infinity because it extends down. There's no limit how far down it goes, all the way up to 4.125. And because it includes 4.125, we'll put this closed bracket here. Again, if you need a refresher on interval notation, make sure you check that video out. And that's how it works in this example. Now, for our next example, we have a circle. And we know that circles are only relations and it's not a function because it does not pass the vertical line test. And here's a graph of what our circle will look like. So here we know that it is centered at the origin because it's x squared plus y squared. And we know that our radius is 4 because it's the square root of 16. It's not a function because it does not pass the vertical line test. A vertical line can intersect the graph more than once, so it's not a function. But even though it's not a function, we can still determine the domain and the range of the relation. So if you can see, for our domain doesn't go any farther to the left than this -4. And we know it's -4 because the radius is 4. And we know it doesn't go any farther to the right than +4. So we can say that for our domain, x is an element of the reals still because it's every real number from -4 to +4. And because it includes both the -4 and the +4, we put equal, not just less than signs. So just a reminder that this is saying that x is greater than or equal to -4, but less than or equal to +4. Now in interval notation, we will just say from -4 to +4 using closed brackets. Now for our range, we're going to look and see that our graph doesn't go any farther below this -4 right here and any farther above this +4 right here. So we can say for our range that y is an element of the reals, again, because it covers every single value between -4 to +4, such that -4 is less than or equal to y is less than or equal to 4. So this is saying y is bigger than or equal to -4 and y is smaller than or equal to +4. For interval notation, we can just say from -4 to +4 like this. And with our interval notation, when we write it like this, it implies that x and y are elements of the reals. So in our next example, we have an exponential relation. And this is what our graph right here looks like. And just a reminder that our domain is going to be all sets of x values that work. So we will ask ourselves, are there any x values that don't work? And I can do 3 to the power of any number that I want, and I will still get a return. So I could do 3 to the power of 7, and I'll get a value. I could do 3 to the power of -5, and I'll get a value. I could do 3 to the power of 2/3. And I'll get a value. I could even do 3 to the power of pi, and I'll still get a value. So there are no x values that don't work. In the circle example that we looked at right here, our domain was from -4 to 4. Let's see what happens if I were to plug in 5 for x. Plus this y squared equals 16. Subtract the 25, I would get y squared equals -9. And I cannot take the square root of -9 without getting into complex or imaginary numbers. So this is not possible. So here it shows you that when we plug in specific values here, we don't always get an output that works. However, with y equals 3 to the power of x, no matter what I plug in for x, I will always get an output. So here we can say that our domain is going to be x as an element of the reals, or we could say that it's from -infinity to +infinity. There is no limit to the left and no limit to the right. It will keep on going this direction and it will keep on going this direction, which means that it's going to go to the right as far as we want. Now, our range is where things get a little bit trickier. When I take any value and I plug it in for x, no matter what x value I plug in, my answer will always be a positive value because there's no way that I could get a negative value by raising 3 to any power, no matter what, even negative powers. Because just a reminder that negative power, so like 3 to the power of negative 2, for example, just means you have to do the reciprocal. So I would get 1 over 3 squared, which is still 1 over 9. So anytime my base is positive, my result will always be positive no matter what. Which is why my graph here is only in the positive values for y. Now, because it's positive, it also means that it does not touch 0. Even though it might look like it touches 0, it never ever touches 0. Now let's explore this. On the graph, it looks like it's touching 0, like especially down over here in this area right here, it seems like it's touching 0. And even the Desmos is telling us it's at 0. However, if you actually zoom in, right here, it's not at 0. Do you see how it's not touching 0? So then when we zoom in and we put our point on the graph, Desmos just rounds down. So because the value is so small, it's getting closer and closer to 0. It just shows it as 0, but it really isn't and you can tell that if you zoom in. So our range has to be still the elements of the reals, but now y has to be bigger than 0. And this time we can't say that it's equal to 0 because again, it doesn't touch 0. It gets close to 0, but it doesn't touch it. In interval notation, we're going to say it's from 0 to infinity, but since it never touches 0, we put an open bracket, and because it never touches infinity, we also put an open bracket there. And that's our domain and range for our exponential function. Now, there are other types of functions that we can look at and discuss domain and range for, but again, like we said at the beginning of this video is just to serve as an introduction to domain and range, and we'll get into more in-depth understanding of what domain and range are when we look at specific functions. That's it for this video. If you have any questions, let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.